Welcome to our series on thermochemistry, and today we're going to be looking at heat and how to measure it. Let's start today by defining thermochemistry. Thermochemistry is an area of chemistry that studies the energy changes, namely the amount of heat released or absorbed during a chemical or physical change. How do we define energy? Energy is often defined as the ability to do work or supply heat. Now let's classify energy. We can classify it in two ways, in terms of potential energy or kinetic energy. Potential energy is stored energy due to position, such as a book resting on top of a shelf. Kinetic energy is energy due to motion. For example, a book falling off the shelf. So the motion of the book falling is kinetic energy. There's also a law that governs energy known as the conservation of energy. And what it says is, during a chemical or physical change, energy cannot be created or destroyed, but can be changed from one form to another. Having defined energy, let's look now in particular at thermal energy. It is a form of kinetic energy associated with the random motion of atoms and molecules. It considers the total energy of all particles. Temperature, on the other hand, is a quantitative measure of hot or cold. It considers only the average kinetic energy of all particles. So when the atoms or molecules in an object are moving or vibrating quickly, they have a higher average kinetic energy, and we say that object is hot. When the atoms and molecules are moving slowly, they have a lower average kinetic energy, and we say the object is cold. Now that we know what thermal energy and temperature are, let's consider heat. Heat is often given the symbol Q, and it is the transfer of thermal energy between two bodies at different temperatures. It flows from a warmer to a cooler object until a thermal equilibrium or balance is formed. So matter undergoing chemical reactions or physical changes can release or absorb heat. If this chemical or physical change absorbs thermal energy, it is termed an endothermic process or reaction. If the chemical or physical change releases thermal energy, then it is termed an exothermic reaction or process. Historically, energy was measured in units of calories. Please note this is not the same as the calories that you see on the back of food packaging. That has an uppercase C, whereas the calories we're dealing with has a lowercase c. The calories that you see on the back of food packaging is in fact a kilocalorie. So what is a calorie? A calorie is the amount of energy required to raise 1 gram of water by 1 degree C or 1 Kelvin. So now that we have a better understanding of the terms and definitions used in thermochemistry, how would we go about measuring the heat entering or leaving a substance? What information do we need? Firstly, we need to know the mass of the substance absorbing or releasing the heat. This is usually measured in grams or kilograms. Secondly, we will need the specific heat capacity of a substance. This is often called the specific heat, and it is the quantity of heat required to raise the temperature of 1 gram of that substance by 1 degree Celsius or 1 Kelvin. It's usually measured in joules per gram degree C or joules per kilogram degree C. The value is specific to the substance that is being measured. So water will have its own specific heat value, iron will have its unique specific heat value, and so will other substances such as copper, etc. So it is unique to that particular substance. And finally, we need the temperature change. And this is measured by subtracting the initial from the final temperature, often written T final minus T initial equals delta T. Delta standing for D, it's the Greek letter for D, and that meaning difference, so the difference in temperature. That gives us our formula that we see below. That Q, which is heat, is equal to M, mass, times C, the specific heat capacity, times delta T, which is the temperature difference, T final minus T initial. So let's have a look at a worked example for measuring heat. A container with 400 grams of water is heated, and the temperature of the water increases from 15 degrees Celsius to 65 degrees Celsius. How much heat did the water absorb? The specific heat capacity of water is 4.184 joules per gram degrees C. So the first thing I do is write down my formula. My formula is Q is equal to mc delta T. Q is my heat is equal to the mass times specific heat capacity times my temperature difference. So what is my mass? It's 400 grams. So I fill that in. What is my specific heat capacity for that water? And it's 4.184 joules per gram degrees C. And of course, write down your units as well. And what is my temperature difference? It's T final minus T initial, which is 65 minus 15, giving me a value of 50 degrees C. Next, I check my units. So I have grams and per grams. They cancel each other out. I have degrees C per degrees C. They cancel each other out, which means the only unit left is joules, and that's my unit of measure. And joules is a unit of measure for energy, so I know I'm on the right track. Next, I just multiply 400 by 4.184 by 50, and I get an answer of 83680 joules. Now I can change this to kilojoules by dividing by 1,000, and that will give me a value of 83.68 kilojoules. The fact that my value is positive means that heat was absorbed. If it was negative, it would have meant that heat was released. Let's take a look at a second example. How much heat must be added to a 310 gram iron rod to increase its temperature from 25 degrees C to 350 degrees C? The specific heat of iron is 450 joules per kilogram degrees C. Again, I write down my formula. Q for heat is equal to M, mass, C, specific heat capacity, delta T, which is the difference in temperature. So I write down my mass. My mass is in grams. I look at my specific heat capacity. It's in kilograms. I can't have two different units of measure. They have to be the same. So what I'm going to do is convert my 310 grams into kilograms. And I'll do this by dividing this value by 1,000. That will give me a value of 0.310 kilograms. Multiplied by then my specific heat capacity of 450 joules per kilogram degrees C. And for my delta T, I'm going to have 350 minus 25. That's my T final minus T initial, giving me a value of 325 degrees C. Now checking through my units, my kilograms cancels with my per kilograms. My degree C cancels with my per degree C, giving you my unit of measure being joules. I multiply the three values together, 0.310 times 450 times 325. Q, the heat, is equal to 45337.5 joules. I can then divide this value by 1,000 to give me 45.34 kilojoules. Here's one for you to have a go of. In your back garden, you have a swimming pool that contains 6.4 by 10 to the 3 kilograms of water. How many kilojoules are required to raise the temperature of this water from 9 degrees C to 24 degrees C? The specific heat capacity of water is 4184 joules per kilogram degrees C. So pause this video and try it yourselves. However, before you do, I just want to point out a few things. So we have our weight of water, our mass, which is 6.4 by 10 to the 3, it's in kilograms. And I also look at my specific heat capacity, and it also has a kilogram unit, so that's fine. But you may have noticed from an earlier example, water was 4.184, and when it was measured in grams. However, when it's in kilograms, notice how it's 1,000 times bigger. So just to be aware of that change, because one of them was in grams, whereas this one is in kilograms. Okay, so just to let you know if you're wondering why it was slightly different there when we used water in a previous example. So try it out and see do you get an answer of 4.02 by 10 to the 5 kilojoules. And as always, the answer is on the following slide. So here's the breakdown of the calculations for that problem. So I have my mass, 6.4 by 10 to the 3 kilograms, my specific heat capacity, 4184 joules per kilogram degrees C, and the difference in my temperature, T final minus T initial, which is 24 minus 9. So when I put all that together, I have my 6.4 by 10 to the 3 kilograms, which cancels with the per kilogram unit in my specific heat capacity. I have my degrees C and my per degree C cancelling out, indicating my unit measure will be in joules. Multiplying 6.4 by 10 to the 3 times 4184 times 15 gives me an answer of 401664000 joules. I divide that by 1,000 to bring it to kilojoules, which is 401,664 kilojoules, and I can put that in scientific notation, which would be 4.02 by 10 to the 5 kilojoules. So that's how we measure heat, and in our next presentation, I'm going to look at calorimetry. Thanks for joining me.